Welcome to this explainer. Today, we're diving into the actual mechanics of how regions track our climate. We're going to look at two completely opposite ends of the spectrum here. We'll start way up high with global policy, and then we'll drill all the way down to the raw, real-time code running in the background of our cities. It's really a tale of two different systems, and it is absolutely fascinating to see how they try to fit together. So here's the core question we have to grapple with. On one hand, regions are making these massive, sweeping promises to reach net zero emissions by 2050. But on the exact same day that a city planner is working on those decades-long goals, they also have to figure out if the downtown district is going to flood next Tuesday. Balancing that macro future with the micro present, that is the ultimate challenge of modern environmental governance. Here's our roadmap for today. We'll cover the Climate Action Toolkit, Integrity Matters, and Regional Pledges, tracking net zero accountability, the shift from policy to raw data, India's weather API infrastructure, and finally, forecasting the future. Let's get right into it. Section 1, the Climate Action Toolkit. Section 2, Integrity Matters, Regional Pledges. Let's start with that global macro perspective. True climate action is really a toolkit, and it's built on two pillars: long-term accountability and highly agile real-time data. Think about it. When a corporation or a city steps up to a podium and pledges to go net zero, how do we actually ensure that means something? Well, that brings us to the H-Leg report from June 2023. This UN-backed framework sets an authoritative standard for credibility, because for a long time, climate pledges involved a whole lot of PR and very little actual tracking. This framework was built to be the antidote to all that ambiguity. And what's really fascinating here is who this framework actually targets: cities and regions. This standard is specifically engineered to prevent greenwashing at the local, municipal level, not just for entire nations. It directly targets the mayors and the regional planners, the exact people who have to implement massive infrastructural changes on the ground. Section 3, tracking net zero accountability. Now, to make those abstract global policies actionable, they have to be distilled into something remarkably strict. Imagine taking all that complex political nuance and forcing it into a checklist. You've got the action item, the recommendation, the specific criteria, and then, this is the kicker, a binary yes or no column. Did the city meet the criteria? Yes or no? As anyone in project management will tell you, if you can't measure it in a spreadsheet, it's probably not happening. This strict binary compliance literally turns lofty pledges into cold, trackable data. Section 4, from policy to raw data. But here's the reality check. While local governments are signing off on these decades-long global promises and filling out their yes/no spreadsheets, their citizens still have to survive today's weather. A net zero pledge for 2050 is fantastic, but it is absolutely useless if you need to evacuate a coastal neighborhood tonight. This creates a stark contrast. On the macro side, we measure accountability in decades, but on the micro side, we need action measured in hours and minutes, what meteorologists call nowcasts. And handling that requires a completely different kind of infrastructure. Section 5, India's weather API infrastructure. To see how a rapidly developing nation handles this microdata challenge, let's look at the incredible infrastructure built by the India Meteorological Department. They've built an entire index of developer APIs, and the localized monitoring gets hyper-granular. They don't just blast out a general national forecast, they break it all the way down from a 7-day city forecast to a district-wise nowcast, down to a specific station-wise nowcast. This right here is the hidden digital plumbing that developers use to build automated alert systems. And it doesn't stop at just rain and wind either. The IMD supplies specialized hydrological and marine APIs to round out the whole picture. If you're managing a coastal region or a complex supply chain, a port warning or a river basin endpoint is absolutely critical infrastructure. This is the invisible data that dictates shipping logistics, agricultural planning, and emergency response, all operating flawlessly in the background. So, what does this actually look like in practice? Well, a developer can ping a specific endpoint, like a city forecast URL, and pull a 7-day weather map, complete with latitude and longitude, instantly. By just making that digital request, any civic application can populate with vital, authoritative climate data direct from the government. There's no bureaucracy holding it up, just instant, seamless data integration. Or consider an endpoint like a district nowcast. Using this, city dashboards can instantly alert citizens of immediate localized weather threats as they develop in real time. Just imagine a sudden severe thunderstorm developing. The endpoint updates, an automated script catches it, and suddenly a million smartphones in that specific district light up with a warning. This is data that is actively saving lives. Section 6. Forecasting the future. When we pull back and bring all these disparate sources together, we get to see the full temporal spectrum of how a region tracks its environment. The timeline scales perfectly. It starts right now with the current weather API feeding live dashboards, expands to the station-wise nowcast predicting the next few hours, scales up to the 7-day city forecasts, and finally extends all the way out to those UN-backed net zero commitments spanning decades. It's one continuous chain of data, connecting a single drop of rain today with global carbon accountability in 2050. So, that leaves us with a pretty massive question to think about. Which tool is ultimately more powerful in the fight to secure our climate future? Is it the macro-level yes-no accountability that forces systemic change? Or is it the micro-level APIs that allow us to adapt and survive day by day?
Right now, if you look across India, you're going to see two completely different realities playing out at the exact same time. On one hand, you have deep, sustained droughts. On the other, extreme, unpredictable floods. In the northern hill regions, dry conditions and soaring temperatures have turned the woodlands into tinderboxes, sparking massive forest fires. But in the south, and states like Kerala, communities are dealing with sudden, violent floods tearing through their streets and sweeping away vehicles. A study from Azim Premji University shows that within the next 15 years, coastal states like Maharashtra, Kerala, and Andhra Pradesh are projected to see their baseline temperatures climb by 1.1 to 1.3 degrees Celsius. That temperature increase triggers the wet bulb phenomenon. High heat and high humidity combine to stop human sweat from evaporating. When your body can't cool itself down, stepping outside becomes lethal. Our current system to handle this relies on the India Meteorological Department reacting to weather events as they happen. The standard procedure involves waiting for an official alert and then scrambling to evacuate riverbanks or lower dam levels. Treating these events as a series of isolated, unpredictable emergencies is no longer viable. The baseline climate has shifted, and managing the fallout after the disaster starts means we are constantly lagging behind the actual crisis. To understand why this 15-year window is shrinking, we have to look thousands of miles away, to the Pacific Ocean. We are currently tracking a super El Niño. This is a massive transfer of stored thermal energy from the subsurface ocean directly into the atmosphere. Global wind currents pick up this excess heat and carry it across the planet, raising the entire globe's average temperature. This graphic tracks the Madden-Julian Oscillation, or MJO, a traveling band of rain and clouds. Recently, the MJO stalled entirely over the Indian Ocean. This creates an atmospheric blockage that traps heat and disrupts normal weather patterns, right where India's monsoon usually develops. In 1997, a localized cooling phenomenon called the Indian Ocean Dipole neutralized a strong El Niño. Today, the ocean data clearly tells us those natural defenses are no longer strong enough to protect the monsoon cycle. Because this protection is failing, states this creates a dangerous squeeze. The rain arrives in short, highly concentrated bursts that can overwhelm dam infrastructure, followed immediately by severe and extremely extended droughts. The fallout hits the most vulnerable populations the hardest. Crop failures drive up food inflation, and prolonged exposure to extreme heat causes sharp spikes in cardiovascular stress, especially among the elderly. The compounding effects of a super El Niño and stalled MJO have outmatched our reactive shields. We need a different structural approach to survive the coming decade. Meeting the 15-year coastal deadline requires shifting the entire model of disaster response from reaction to proactive technological adaptation. Addressing the current policy gap requires a framework like Teraom, technology-based environmental resilience and ocean management. The first pillar of this strategy focuses on the air itself, using direct air dust capture, or DADC technology. These units actively scrub the outside atmosphere. They pull in the dangerous particulate matter caused by extreme dry spells and forest fires, which physically lowers localized warming factors and improves air quality for local residents. The second pillar focuses on the power grid, specifically the need to decouple our cooling infrastructure from fossil fuels. During heat waves, a traditional grid often buckles under the massive spike in cooling demand. Decentralized renewable grids can balance this surge, preventing blackouts while ensuring we aren't burning more coal just to stay cool. Implementing these technologies moves the burden of protection onto the municipal infrastructure itself, creating a permanent buffer for vulnerable coastal communities. Securing India's water, food, and long-term livability depends on policymakers and civil society embracing this technological strategy today. The incoming El Niño is a mirror reflecting an unavoidable reality. The 15-year window is closing. Transitioning to a proactive technological model is how India meets that deadline.